right, children. So, objectives today. Find domain range of a relation. Determine whether a relation is a function. Determine whether an equation represents a function. We're going to evaluate a function. Graph functions. Use vertical line test. Obtain information about functions and graphs. Identify domain range of a function from its graph. Identify intercepts of a function. So it's got a lot of objectives for today. But the biggest idea, again, these are just basics of functions and graphs. A lot of the stuff will be repetitive for you. You will already see this. If you haven't, please let me know. I'm under the assumption that now we're kind of starting treading new waters, but it's really not. We might just expand a little bit on what you already know. Okay? So, if I say something that you don't know about, please ask. Okay? Now, a relationship is any set of ordered pairs. The set of all first components of the ordered pair is called the domain. Therefore, all the x values are the domain. And when we ask you for domain, all we're really asking is, what values of x does this function take on? Make sense? What can it or can it not be? And of course, range is going to be the other component, which is going to be the second piece, which is the y. And it's the same question, but for the y values. What components or what values does this function take on for y? Questions on domain range? Everybody remember what that is, kind of thing? All right, coolness. Let's move on. So in this case, they asked me to find domain and range. My domain should be 0,
10, 20, 30, 40.
This is so difficult. And of course, all the range values would be the second components, 9.1, 6.7, 10.7. Hey, would it be okay if I said the domain is, let's see here, what do we have? X is less than or equal to 40, less than or equal to 0. Would that be okay for my domain? Can I do that? Because my lowest value is 0, right? And my highest value is 40. So would that be okay if I just said, hey, you know what? The domain is all values from 0 to 40. No? Why not? Skulls?
Because it's like the in-between numbers aren't numbers that aren't within the thing.
Right. That's absolutely true. We don't know how this function really is behaving altogether. Yes, we do know that most functions are smooth and continuous, but sometimes you can get these things called piecewise functions. And we really don't know how it's behaving between 0 and 10. It might be that this comes from a rational function, and maybe some value that's between 0 and 10 breaks my denominator. So when I'm given a data set like this, a set of relations like this, I want to just stick to what I know and not assume something that's not true. Okay, so don't do that. A function corresponds to the first set called the domain. The second set is called the range. There's input, outputs, all these other nice fancy words that we've heard from before. Now, in order for something to be called a function, the domain corresponds to exactly one element in the range. And when I was in college, this makes perfect sense to me. I was like, cool. Now it gets a little twisted. So I'm going to tell you the story the way that I heard it, and hopefully I don't offend anybody. But here's the way it goes. Professor says, hey, the guys are X, the girls are Y. Okay? And the guys can only be with one girl. That's the rule. In order for a relation to function, every guy can only be with one girl. And that's it. That's the rule. Okay? Do you understand the rule?
Yes.
Every guy can be with one girl. Do we tolerate cheaters? No. Both. We don't tolerate either. So, and when he told me that, I'm like, oh, that makes a lot of sense, right? We don't care about the girls' behaviors. Girls could be with as many guys as you want. That's okay. Guys, there's always that one guy's like, no, wait, man, I'm a player. Shut up. But it makes sense. And then later on, we'll talk about these other types of functions. Those are called one-to-one functions. Guess what type of relationship they're in? They're in a monogamous relationship, right? 1x to 1y, 1y to 1x. But for now, in order for for relations to function, every guy can only be with one girl. And that's what we care about, okay? It makes it so much easier when we're checking data sets to see if something is a function or not. Like in this case, is this a function or not? And I can already tell you it is. It's not? Yeah. And it's this quick. Who do we care about? Guys. Guys can't be cheating, right? So all I have to worry about is all my guys. Guy number 1, guy 3, guy 6, guy 8. Did any of those guys repeat? Yeah, because guys are x, right? Now, did any of those x repeat themselves?
No.
So do I need to worry about at x any guy cheating in here?
No.
Therefore, it's a function. That's simple. Do I need to worry about the y values? I don't. Okay?
Oh wait, because it can't stack on top of each other, right? Like the points are.
Right. So now you're thinking visually, correct? And that's why we do the vertical line test, because that vertical line test will tell me if some guy has a girl on the north side or the south side together, and that's not okay either, right? So, everyone okay with that? Check the x. As long as x does not repeat itself, we're good. Now, what if I did do this though? What if I added another point and I said 1 comma 2? Ooh.
It's still.
Ooh.
It's twins.
Wait, they're together twice. Wait, but it's
No, that's creepy, bro.
still a function
Why is it still a function?
because of the same point. They're not over. Like they're not. It's not overlapping.
Girls, is taking the same girl on a second date cheating? If you're taking out the same girl on the second date, it's not cheating. Okay? All just means that you like each other a little bit better, and now we're gonna get some chili on those fries. Ooh. I love chili. All right, cool. Now, is this a function or not? Is this a function or not a function? Anybody recognize this from last year? Yeah. What is it? It's a circle. If you can't see it, you're gonna have to learn how to graph it on your calculator. Decimals is great. Anybody use decimals? You can actually throw that into decimals and it will graph your circle. I wish decimals had a handheld. Swear to God, I would like drop TI in a heartbeat with that.
Does square root of like the number? Isn't that like the radius?
Yeah, the square root of the solution? Correct. So, yes, this is a circle when we graph it, and the circle with a radius of 1 in this case. Not important. What is important is that if I use my vertical line test, yeah, this x is cheating. Got a y value up here and a y value down below. So this is not a function. You guys remember that vertical line test? Cool beans. Any questions so far? Good. String better. All right. Function notation. Function notation. This right here is read f of x or f at x. The value of the function at x. Make sense? I usually do f of x. Just kind of the way I've learned. If you want to start changing your habits and call it f at x, I think you're going to be cool. You're going to sound cool. Okay, so f of x it is. So, here's what's beautiful about function notation. Equation notation is hard. What are you talking about? So, equation notation, let me do equation notation real quick, okay? So here's what I know. Let's say I did have this function, y equals x squared minus 2x plus 7. And I said, hey, can you evaluate this for me? Go for it. Yeah, you say, I don't know. What value of x do you want? Right? And then I have to say, oh, can you evaluate that when x is equal to negative 5? Then you go, oh, okay. Then you go, y is equal to negative 5, x squared minus 2 plus 7, right? And then you go through your business and you evaluate it, correct? The nice thing about function notation is that it's there, okay? So when I'm going to evaluate this, I'm going to evaluate f at negative 5. And then I've got this business going on. What happened to my x? What did it become? So what happened to all the other x's? And then I evaluate. So that means that f at negative 5, sorry, now I'm doing it, 25 plus 10 plus 7, f of negative 5, what is it, 42? This gives me much more information than the equation does. Because in the equation part, thank you, when I do equation notation, I know what y equals, and I got to go find what x equals to begin with. While here, I know that when the x value is negative 5, what's the value of the function? 42. This is an ordered pair. I've got a relation here. I know this just by looking at that piece. Does that make sense? So function notation, you want to get used to it. If you don't like it, learn it. Because that's going to be our basis for calculus.
There's so many of those.
Go ahead.
I hate to be that guy, but I think there's a moldy French fry in here.
Yeah,
Oh, whoa.
it's an experiment.
Is it really? Wait, is it really?
No,
Oh.
not at all.
Get it.
And it's not a moldy French fry. It's just that stuff that they have up there. Why would there be a moldy French fry?
That's why I was tripping. It looks like a moldy.
And if it was from McDonald's, it wouldn't get moldy. All right, so. Did I say that live? Moving on.
Can you go back?
Can I go back to here?
Yeah, thank you.
You're welcome.
A snack. A snack.
Yeah, no.
It's a snack. Snack is a snack.
That's like straight up food poisoning.
Alright.
You good? All right, let's move on. The graph of a function is the graph of its ordered pairs. The graph of a function is the graph of its ordered pairs. Even though when we graph something, like let's say we were graphing y equals x. Actually, let me change that. If we were graphing f of x equals x, what is this? What do we call this usually? Starts with an L, ends with an I. We usually call it a line, right? But in fact, this line is composed of many what? Ordered pairs. There are just so many of them that they start to stack on top of each other and you get that shape. Okay? That's why we get scatter plots. That's that same idea. Starts producing the image that we're looking at. So, vertical line test. Vertical line test is really that. If you draw a vertical line through the graph, at any point, and you hit 2 points, then not a function, right? So, this a function? Is this a function? Is this a function? Is this a function? No.
Also says that.
All right, cool beans. So, sometimes you're going to have to analyze based on the graph. So in this case, we have, what's the value of the function when f is 5? Well, I'd have to come over to x being 5, right? It's right here. I'm going to come up to the function, and then I can figure out what the x value is, which happens to be 400. Okay? If I want to evaluate f of 9, I've got to come over to where x is equal to 9, come up to the graph, and it looks like it's about 100. That's why my question mark is there, okay? It actually is about 25, but close enough. Okay? You guys cool with that? Raul, Omar? You guys are good? All right. There we go. This is good stuff. Find the main function from its graph. Find the domain and range from a graph. Remember, domain is simply what values of x we're taking on. The range is all the values of y that we're taking on, okay? So let's do that real quick, yeah? I want it to. I want it that way. What did I do? Here we go. Thank you. So let's start with the domain. And here's what I'll do. Because we always read our graphs the way we read our books. We actually read all math like we read our books, from left to right, okay? So I'm going to go on my x value for starters, and I'm going to start at the smallest x value possible. And then I'm going to just kind of scroll across until I find the highest x value that this function takes on. And that, right there, represents my domain. So my domain, in this case, x is less than or equal to 2, but it's greater than or equal to, oh sorry, that's not a 2. It's a 1. And there's my domain. There's my domain. Questions? Cool. To find my range, it's going to be the same idea, except I'm going to do it on the y-axis. And I'm going to go from lowest to highest. In this case, my lowest y starts, right about here. And it goes all the way up to right about there. So my range in this case, 0 equal to y, less than or equal to, what is that, 3? And there we are. Questions? Kaker? I don't know what that was.
I was explaining to her that your foot's supposed to be as big as like your wrist here.
Your what?
Your foot.
I don't think that.
It's
Big
supposed to
ass
be
foot.
what? Higher reach than or something. This is huge.
Find me the domain and range of this, please. Go. And then I'm going to call somebody. Yes, I will.
Oh, yo, that's open.
Oh.
What do we have to do?
I got you, Mr. Munoz. You want the range as well?
Yes, domain and range. So I found my stats medic stickers for my extra class. Oh. And I still put it on. So you do.
If I give you an Apple sticker, you want it? Okay.
Sorry. Thank you for the thought though.
Do you want a scrunchie, Mr. Munoz?
A scrunchie?
Yeah.
Not right now.
So you can do this color.
Hey, Mr. Munoz, I got a question.
I have a question.
How come you got a beef stew on the cell phone?
I have a question. Why don't you have beef stew?
I got it in the cabinets at home.
This is my house. No, we were doing, so I grew up in Southgate, California, and we know when we do the food drives, people bring stuff in, and a kid brought it and said, here, Mr. This is for you, this is from Southgate, and you see it says Southgate at the top. So,
Self-gate or self-gay?
touche.
Oh,
Sharpen that can, right? Those things will cut you. You never try to open up a can all the way around? You gotta be very careful. Be careful. All right, here we go. Question goes to random. Lorenzo. Oh. You know what? No. Do domain and then you pick somebody for range. No, we'll let the dojo do it? Okay. What's your domain then?
Less than no line underneath X, and then less than
You don't have to say no line. This is less than, and this would be less than equal to. Huh? Oh, sorry. Did you say -1? Oh no, it's gonna be a +1. That's what I thought he said, but I wrote the negative. I don't know. Good job, brah. All right, so range. Range goes to. You want to pick it? Go for it then. I did say that first. Go ahead. Who is it?
-1 is less than y.
Oh, I used that.
2.
Did you say less than? 2?
Yes.
Okay.
You're wrong.
Hey, whoa. Whoa. Let me help you with that. Hey, how about you take a look at the other part here? Hey, look at that point. Is it open or closed?
Oh,
Let's be supportive here.
less than or equal to.
Good job. We're on this side, right? Because it's a solid. Okay. All right, we're good. So rude, bro.
I'm not wearing this. It has to be.
Oh, it's not on the second one. It's on the first one. Because we start from the bottom, right? And then we work our way to the top. Thank you, Lily. Good job. That will slip by me. Are we good here? Questions? Give me a thumbs up if you're good. Thumbs down if you're not. Boom, let's go. Am I going too fast? Are you guys okay? Is it just right? Or am I going too fast? Soraya? Am I going too fast or are we good? All right. Okay. Let's move on. Come on, we're almost there. Stay with me. Stay with me. How do I find an x-intercept?
Oh, you said, y zero.
Make y 0. How do I find an x-intercept?
You said y zero.
Make y 0.
Just said the same.
How do I find the origin?
You just go
Make
zero.
both 0. Sorry. Stupid joke. Here is
Divide by zero, teach.
a function can have more than one x-intercept, but at most one y-intercept. Okay? And I want to underline this. A function can have more than one x-intercept, but it can only have one y-intercept at most. Okay? Just one more slide and then
No, wait, let me write that down.
I can do that.
Oh, yeah.
Whoa, whoa, whoa. You got too much dip on your
Maybe if
chip.
you had it from the graphic.
I want to learn to roll a coin on my knuckles.
Like, oh, yeah.
You never seen that? They'll take a coin and then they'll go like blah 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 blah, and they'll pick it up and blah 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 blah. It looks really really cool, but I'm like clumsy.
Like, or really hold a pen between your fingers.
Oh, really flick it?
Just like something like that.
Oh, that was well done. You look like a pro. No, there's some where they flick it and they'll spin and then they catch it and they flop. Yeah. I can't do that. You guys ready? All right, last slide. How many intercepts does this bad boy have?
Which ones?
How? Oh, good question. How many intercepts does this thing have? Malia, how many intercepts? How many intercepts? Beautiful, well done. So, 1, 2, 3 on the x, 1 on the y. That's important to know. Because I could actually create the whole equation just by looking at that. Like, can you give me the equation of this bad boy?
I could if I had the equation.
And we'll probably do this again, but because I have a little bit of time right now, I'm going to use it for this. Here's what I know. I know that x is equal to, what is this? -3? X is equal to -1, and x is equal to 2. Right? So here's what I'm going to do. I'm going to convert those back into binomials. This would be x plus 3 is equal to 0, correct? This would be x plus 1 is equal to 0, and x minus 2 is equal to 0, right? Because all I did was go plus 3 to both sides, plus 1 to both sides, minus 2 to both sides. So I got all the numbers on one side, and this all ends up being 0. I can do that, right, algebraically? Who asked why? Is that still okay? Okay. At some point last year, you should have used what's called the zero product property. You guys remember the zero product property? If you had two binomials and the product of the two equals 0, then one was 0 or the other one was 0, correct? Because that's kind of what you have to do. Well, guess what? These guys are binomials, and they're all equal to 0. Therefore, I can take x plus 3 times x plus 1 times x minus 2. That product should equal 0 because they all equal 0, don't they? And once I distribute this all out, that will give me the function to this bad boy.
So you just leave the -6 alone with that.
Huh?
If you leave the -6
No, because that'll adjust itself. That will take care of itself. Guys, we're done. Let me turn this off real quick.